Hello, this is Dr. Mode and welcome back to chemistry class. Today we're going to continue our chapter on acids and bases, but we're going to start section 3 on pH. Our verse for today comes from Psalm chapter 100. Make a joyful noise to the Lord, all the earth. Serve the Lord with gladness. Come into his presence with singing. Know that the Lord, he is God. It is he who has made us, and we are his. We are his people, and the sheep of his pasture. Enter into his gates with thanksgiving, and his courts with praise. Give thanks to him. Bless his name. For the Lord is good. His steadfast love endures forever, and his faithfulness to all generations. The big idea for Chapter 18 is that acids and bases can be defined in terms of hydrogen ions and hydroxide ions, or in terms of electron pairs. As you can see that we've finished Section 1 and Section 2, and we're starting Section 3 today. So the plan for the week is to get through Section 3 and Section 4, and then be finished. The essential questions for this section are: what are pH and pOH? How are pH and pOH related to the ion product constant for water? How are the pH and pOH of aqueous solutions calculated? The ion product constant for water. So if we look at this reaction that's reversible, so you see the arrows go both directions, water will dissociate into a hydrogen ion and a hydroxide ion. So if we take the concentration of the hydroxide ion and we multiply it by the hydrogen ion concentration, then that gives us a constant for water. And that constant is Kw. Kw always equals 1.0 times 10 to the negative 14th at room temperature. So this is a table that I've shown before, and you can see the second column there shows pH, and this goes all the way from acidic conditions to basic conditions. But the last two columns show in all of these conditions what is the hydrogen ion concentration and the hydroxide ion concentration. So you can see that the numbers start at 1 and then get very small for hydrogen, and then it starts very small and then goes up to 1 for the hydroxide ion concentration. But if you were to take and multiply each of these lines together, so the 1 and then the really small number for hydroxide, you would get 1.0 times 10 to the negative 14th. And that's going to hold true for every line as you go down. You're always going to get this same number, 1.0 times 10 to the minus 14th. At 298 Kelvin, which is room temperature, the H plus ion concentration in a cup of coffee is 1.0 times 10 to the negative 5th molar. What is the hydroxide ion concentration in the coffee? So what we're going to do is we're going to use our equation for Kw, but we're going to solve it for the hydroxide ion concentration, the number that we're interested in. So Kw is always the same. It's 1.0 times 10 to the negative 14th. And the H plus concentration is given in the problem, 1.0 times 10 to the negative 5th. So what we need to do is divide these two numbers to find that the hydroxide ion concentration is 1.0 times 10 to the negative 9th molar. Now, some people have a lot of trouble typing these into the calculator and getting the appropriate answer. So I suggest that you practice this with your calculator. But one thing that you should notice is that when the numbers are given as 1.0 times 10 to the something and 1.0 times 10 to the something, that it turns out that when you divide, what you end up doing is you subtract the exponents. So if you have 10 to the negative 14, you're going to take negative 14 and you're going to subtract a negative 5 or add 5. So negative 14 plus 5 ends up being negative 9. So that's a trick, but it only works when you have 1.0 as your concentrations. So I'm sure that you've heard of pH before, and pOH is a similar concept. So let's talk about what these actually mean. So pH actually comes from the hydrogen ion concentration. So that number that we've worked with a couple of times now, if we take and put in our calculator the negative log of that number, we end up with the pH. So this basically changes that from a scale that gets to be really small numbers to numbers that are reasonable, that change in between 0 and 14. So the pOH is very similar. So pOH is the negative log of the hydroxide ion concentration. And again, this is going to change between 0 and 14. So one thing that's convenient is that if you know pH or if you know pOH, you can figure the other one out using this equation, because the pH plus the pOH always will equal 14. So what is the pH of a neutral solution at room temperature, 298 Kelvin? So a neutral solution is going to have a hydrogen ion concentration of 1.0 times 10 to the negative 7th molar. So we're going to need to use our pH formula and plug in that number. So we're going to plug in 1.0 times 10 to the negative 7th and take the negative log of that number. And what we're going to find is that corresponds to a pH of 7.